So we're very excited to announce that we are taking these laboratories on the road. Our drivers who can help us to travel with this rig because we're taking all the lab equipment that's required to conduct these laboratories. So if you don't mind driving, and we're not talking about a large, heavy driving schedule, maybe 2 hours on, 2 hours off, that sort of thing. We could use your help, so please let us know if that's something you're willing to help us with. These are photographs that students took of the nerves that they found in the workshops in Pennsylvania. I'm telling you, the electricity in that event was amazing. The kids just get so excited. But it's a real learning experience for them because they get to handle these things and work with them with their own hands and eyes, see these things with their own eyes. So it's really a revelation for them. And they get to take their pictures home. This is a blood vessel that they found right here. That's a vessel. And of course, this beautiful nerve that a student named Seth found. So it's really a lot of fun. They get to look at the serrations on teeth, even under electron microscopy. So we're hoping to do a lot of really cool things at homeschool communities around the country. So we would ask for your support in prayer, particularly. That's really what we need most of all. Well, let's talk about fossil bone, because a lot of people are under the impression that everything that's fossilized, which is a technical term, simply means it's been in the ground, preserved, whatever preservation means to you. The term fossilization or fossil is something that's buried in the ground that was once alive, or created by something that was once alive. So, but when it comes to bone, we're still finding bone. They're not permineralized. And so we can use the same laboratory protocols that are used in hospitals every day of the week to dissolve these bones. We put them in a chelating agent, which kind of deconstructs the calcium. And so as the calcium falls apart, all of the veins, all of the vessels, the osteocytes, which are the beautiful cells, and of course the nerves, they all fall out on the bottom of the dish. And you saw that one circled nerve, right? It was a little hard to see, wasn't it? I had to jiggle that jar so you could see it moving while I was filming. But all of this stuff falls out from where it was found in the bone. There are bone canals in your bone and in these bones. And within those bone canals are the vessels, the veins, and the nerves. They travel in a triad. So we expect to find these, and we do find them. The other thing we find a lot of are these osteocytes. It's off camera a little bit here. You can see all these little dots in here. Those are all osteocytes. Those are the bone cells that actually repair your bone and make new bone. Did you realize your skeleton is replaced just about every 15 years? Completely. Your skeleton is completely recycled every 15 years or so because of these cells. So they're very active in your bones all the time. They're measuring your compression while you're running, carrying things, and they find cracks. They find micro cracks, and they send other cells to repair those. So there's a whole city, a whole universe of living tissue doing things inside your bones, even now. What we're finding is that the canals are filled with what? Well, that was our question. You're going to see thin sections that we've made of these bones today, and you're going to see dark areas that we believe to be clots. And so we studied those with a special microscope, a UV microscope, and we got the clots to autofluoresce, and I'll explain that as we go along. But all these canals, or most of these canals, are still filled with clots. Now, that's going to become important later on in the lecture. You'll understand why the clots are significant. And these clots will autofluoresce. They will give off light if you hit them with a high energy light. So we're using light around 350 nanometers in the UV region of the spectrum. It would burn your retinas off, so you have to use special glasses to work with these instruments. But the iron gives off its presence by glowing, and you're going to see that. And so our conclusion is the blood never left the canals. And so that's significant for a couple of reasons, as you see when we progress here. So here's a thin section of Triceratops. I think this is horn. And you notice all the bone is kind of brown, okay? It was white. Your bones are white in the living state. And so this kind of got colorized over time by being in the ground. There's a couple of processes that they describe that kind of like toasting a piece of toast slowly over a long period of time. And again, these have been in the ground a long time. I mean, these are ancient bones, right? They're maybe 6,000, 8,000, 10,000 years old, but that's ancient to me. Isn't it ancient to you? Yeah, okay. So these are ancient structures, so they're going to age with time, and they have. But all of the structures, the soft structures, are still in there. So in addition to this sort of sandy brown color of the bone, you have all this dark stuff. And we noticed this in section after section after section that we were making on these bones. And so we decided we were going to study them with UV, and this is the result. So when you look at these under a light microscope, you see that the clot is very dark, and it completely fills the lumen, which is the opening, the space in the blood canal. So this once has housed a nerve, a vessel, and a vein, okay? But the blood erupted out of that. Sometimes we find the veins and vessels, sometimes we don't. But it clotted. And so you can see that nice and dark in a bright field microscope. And when you switch to the UV, okay, you see the iron glowing. So we published this. This was in 2020. This was September of 2020 in Microscopy Today. UV autofluorescence shows clots in these bones. And so we tested 7 different individuals, all triceratops, and every single one of them yielded these glowing clots. But notice that the iron is restricted to the canals. It hasn't migrated out into the bone. It stayed in the canals, and that's very important because it kind of replies to the current reigning theory that iron is what's preserving the soft tissues. If the iron didn't migrate out into the bone, how did these tissues that are preserved get preserved? You see? So we don't think the iron is doing the work that they're claiming that it is doing. This is a piece of frill, and one of the things you can see here is this very sharp line of demarcation. So there's a nice separation between all of the iron, which is glowing blue here, and the rest of the bone. So you can see that it's definitely separated from the bone itself. It remained in the canal. Now remember, these are thin sections that are polished down about half the width of one of your hairs. But you can still see the clot going down in the canal. Even though it's only 40 microns thin, you can still see the clot moving down into the canal. So these are there. They're difficult to dislodge. These bones were processed through regular fixation and dehydration protocols, and so nothing was dislodged during our processing. So these are solid. Now we call this clear evidence of DIC. Well, what's DIC? Disseminated intravascular coagulation is a medical condition. It's in the literature, and it's a condition that shows whether or not you died by drowning. When they rescue a person who's drowning or an animal that's drowning, generally their blood has already started to clot. It's a physiological response to being anoxic, not getting oxygen, but also the terror that the organism is going through when it realizes I'm dying right now. Okay, that terror can cause clotting. In fact, there are studies that show that people who live under high amounts of stress suffer from clots. So it's a physiological response. When they rescue a drowning victim and they get them breathing again, that blood clotting cascade, right, which is what it is, it's a cascade that goes in one direction to clotting, reverses and starts going the other way. And now your patient is bleeding out in the ER. And any ER physician will tell you that they've had to deal with this when they resuscitate a drowning victim. But if you die in that condition, your blood stays clotted, you see. So it's a wonderful Polaroid snapshot showing that these things actually drown. They died by drowning. So it's a pretty significant find, we think.